Pessoal, vamos começar. Já começou a transmitir. Bem-vindos, pessoal. João obtained his PhD in astrophysics from Warwick University in the UK, and then held a few postdoc positions in Australia at Macquarie University and the Australian National University. He then joined IntelliDots, a software automation company holding several positions focusing on software development, architecture, and cloud engineering. And he started in 2022, he started a position working for the New Robotic Telescope project at Liverpool João University as a DevOps and software engineer. So when you are ready.
Okay, thanks. Thanks for that, and thank you for the opportunity to be here and talk to you today. I think this is the first seminar this semester, so an honor to be here a little bit. And unlike all the other ones, I'm not going to talk about astronomy at all, but I'm going to talk about something that we probably do more than astronomy on a daily basis, which is programming. Okay, and this is, I'm going to try and keep it brief on most of the topics, particularly because we sent a survey around to ask what people wanted to hear about, and I'm going to try and cover most of the topics that had quite high level. However, I am here for the next month or so, so if you are interested in anything that was in that survey that I didn't talk about, just come and talk to me around, and I'll be here for most of this month anyway. What am I going to talk about today? So I'll make a bit of an overview of what this actually is, right? But I'm going to spend a large portion of my time talking about version control, right? And we'll get there in a little bit, right? And then some good coding practices. Most of this stuff comes out of my personal experience and also experience with talking with other people and what works and what doesn't for the last 20 years or so. And I'll briefly talk about Jupyter notebooks, mostly because I want to make sure that it's well understood. I feel like they are often overused, and I'll talk a little bit about why I think that's the case. And then I'll talk a little bit about integrated development environments, which I think most people these days tend to use, but maybe you're not quite aware of why you would want to use one. And then I'll have some final thoughts at the end. So the idea of this talk, and I've given it a few times, and I always talk about the concept of what good software and good code looks like. And I think that there's no such thing as perfect code, but there are plenty of examples of really bad stuff. So the idea of good code is usually something that I'd like to describe as a journey. The journey towards good code is what we all want to do, right? And we always start doing something badly. And even that concept of what it is actually evolves over time anyway. And the motivation for having a talk like this is that astronomers and data scientists and people who do this kind of stuff, right? We're ultimately just programmers. That's all we actually do for most of our time. But the difference does tend to be that we don't have or have very little formal training on what it is to actually do software engineering. So people are often mostly self-taught and very results-oriented, right? And what I mean by that is that actually, when you look at software development in academia versus industry, there's different purpose, different team size, and different focus. What I mean by that is that software development in academia is more like, this has to do the right science, has to do the right thing, what we want it to do, right? And when you're actually working in an industry setting, most software, particularly if it's an industry that sells any part of that software, the focus is very different, the purpose is very different. I mean, the purpose when you do it in industry is to make money. It doesn't necessarily mean the code will be good, it just means that it just make more money. But also the team size tends to be very different. You are more likely going to be working with lots of people. And the focus tends to actually be to make sure that the code doesn't break.
João, can you come a little closer and speak louder because people are online?
Sounds good. So on that basis, right, I'm going to just jump straight in onto version control systems, right? And if you've never heard of version control systems, hopefully you will have heard of something called Git. And you've either used it for a little bit or heard about it, and somebody's told you it's probably a good idea to use that, right? And I've given this talk in the past several times, and I usually used to start with There are various kinds of version control systems, centralized and distributed version control systems, things like Mercurial or Subversion or Git and etc. However, in the last few years, Git has just been shown to have such a huge dominance that I'm even going to make a statement that might be controversial, but I think that in the history of computing, there hasn't been a single piece of technology that has dominated as much as this, right? So almost everyone in the world, and I mean that like 93.8%, and this was only in 2022, and this trend has not stopped. Anyone who chooses to use version control systems these days pretty much just uses Git. And it's just completely dominated. And anyone who isn't is often migrating towards it anyway. So in many ways, this may be actually being comfortable with using Git might be one of the most valuable things you get as your experience in academia, because it's the kind of thing that everyone else uses all the time, right? So what is it if you've never heard of it, right? So the idea of a version control system is that it's supposed to track changes to your code, but actually, really what it does is it tracks changes to files, right? Text files particularly. So it doesn't actually have to be used in software. It could be used in all sorts of other things. But generally speaking, it's used for code, right? And it's also useful for tracking who made the changes to every single piece of software. Now, why is that important? Well, sometimes people break code, and you want to be able to blame who did that. It's kind of fun. But also, more importantly, it actually allows you to have different versions of your code happening simultaneously in a system where you don't have to keep on doing things like naming your files with an underscore v2 and v3. That's rubbish, right? So this is what it's really for, right? And it's pretty much critical if you want to collaboratively work on files with other people. And I'm being deliberate when I say files, not just code. Files may include things like LaTeX files for your paper or something like that. You may have different authors, you may want to do things differently. You're going to write a thesis at some point in your degrees. There's a good chance there will be multiple versions of this thesis, right? And LaTeX files are just files, so you can still use this kind of stuff, right? And just as a curiosity, it was invented by a guy called Linus Torvalds, right? Who was actually the inventor of the Linux kernel, because he didn't think that anything else that existed before was good enough for the kind of team that was beginning to develop for the Linux kernel. When you start having a team of more than, say, 10 people, and the Linux kernel these days has got thousands of developers, most of whom have never met in person, you need something that works with this kind of thing, right? And it's not the same as GitHub or GitLab. Just to make that point, I get that question a lot, right? Git is a technology that places like GitHub and GitLab use behind the scenes, right? And it's a distributed version control system. Now, this is just to give you just a quick overview of what that actually means, because there are version control systems where it behaves slightly differently. But the idea is that a Git repository is something that contains the information and the history of all of your code. And you might have a central location, which is usually hosted on somewhere like GitHub or GitLab. But actually, each individual computer for each individual developer will usually have the entire repository, or at least that entire repository up to a certain point in time. So actually, whenever you clone and want to do contributions, you actually bring the entire thing to your local computer. Now, this may seem inefficient, but there are several good reasons why this is the case. And in the past, centralized version control systems didn't have this layer here. It was just one place, and you would just only bring what you needed. But these days, because it's a good practice to have small repositories, bringing everything means that if for some reason the big one dies, everyone has all of the information in each other's computers. It just creates redundancy. And so when the time comes, if you want to start using it, for those of you who've never used it, right, here's a link, and I'm sure we'll be able to share these slides with everyone at some point. You just head to the Git homepage and you install it for your own system, and effectively, you've got to do something that is often overlooked, which is that you've got to configure in your system on your own computer, basically, who you are and what your email address is, so that every time you make any change to the code, this is what I meant, right? It's supposed to track changes and who made the changes. And this is how you tell your system, this is my name and whatnot. You've got to run those two little things. And then when you want to start using it, you might go to the directory that your code is already in, and you just do this thing called git init. And just as a curiosity, and just so you know what's actually happening behind the scenes, all it does is it creates a hidden .git folder inside of it. which is going to contain not versions of your code, but information about all of the changes that happened all the time. Yes. Or, which is also another way that you may want to do it, you may simply want to clone a repository that's already hosted somewhere, like GitHub or GitLab, and just bring it into your own system. And it basically brings all of the code plus that hidden directory that contains all of the information of the entire history of the code. Does that make sense? Pretty much, it's fairly simple to use, right? And actually, the main concepts, and I'm just going to push it over here. The main concepts you need to do, and I would say 99% of the time that you use and interact with Git, you're doing effectively just the same thing, which is you tell Git from your working directory which files inside that directory Git needs to care about. And it's entirely possible for you to have other stuff in there that you don't want Git to track. So you basically use a command called git add, or if you're using a graphical interface, which is basically add stuff, into what's called a staging area. And you can have multiple files ready to go. And then you basically do a commit. The commit is basically the action of saying, here's a bunch of changes I made to one or a few files, and I want to put a message against it. The message might be, I've updated this function and this configuration file to do what, right? And that's what actually the Git history contains. It's literally just a list of commits, a list of tracked changes in the particular code. And once that happens, only your local repository, the one in your computer, actually contains these changes. So in order to make it available to other developers, you basically have to push it up to what's called a remote repository. And this is what really GitHub or GitLab is really useful for. That's where you host it. It's kind of like a central location, right, for everyone to come to. And then whenever it's time for you to pick up where you've left off, if people have made changes to it, you will usually start by doing a git pull, which even if whether or not you already have the repository locally, it just brings back those changes. And basically your local repository is up to date, and you can make all of the changes you want to, and then follow this cycle this way. Does that make sense? And so here's my tips for you when you start using this, right? I try not to have commitment issues. What I mean by that is you should be committing very often, right? And the word commit feels very final in the sense that, oh no, am I sure that this is what we want to do? But it's just a word, right? It doesn't matter. You can always go back in history. You can undo stuff. The idea is that this allows you to go back in time, make changes. More importantly, compare with your last commit, just in case you broke something. So just committing often and lots of stuff is a good idea. And commits are not new snapshots in the sense. It's not a copy of the entire thing with a slight change, right? It only keeps tracks of the things that actually physically change. And I would say put informative but short messages on your commits. If your commit message is a massive paragraph, that probably should be several commits, right? If you're just committing a whole load of stuff, you can do it progressively and slowly. And push often to make sure that everything is available for everyone else. And the main part of Git here and the main strength is that you should use branching for parallel work. And we're going to talk a little bit about that in a second. And you should use pull requests for collaborative work. Basically, a pull request is exactly equivalent to the peer review process in astronomy. When you submit a paper, before it gets accepted, it's looked at by someone else. That's exactly what a pull request is meant to be, right? Some other developer will look at what you've done, make comments, and decide if that's good. And so this is just a quick page. I'm not going to go through this very, very quickly, but if you get the slides later and you're struggling with this, effectively, in order for you to do stuff with GitHub, you need to basically tell GitHub to trust things that are going from your computer up to it, right? And you do that using SSH key generation. So on your GitHub, you can go to settings, basically, and there's a bunch of places you can do the SSH key. And you basically only need to do this for only once for each computer that you normally push from, yeah? And you add them in there, there's some instructions, and effectively, you add the keys to it. You generate them on your computer, and you basically say, look, here's a key. You should trust anything that's coming from this computer. And I'll finish off here just saying that cheat sheets are actually a good idea. There's 3 examples in there, but there's a million of them. And these are the kinds of things you can print off in an A4 piece of paper if you're just starting out, or even if you're not, if you already use it quite a lot, but sometimes it's like, how do I do this, or how do I Google it? there's a few ones in there with all of the commands that you need. Stick this on your wall and it'll just be better. Yeah. And I'll actually, this is just a bunch of text. Don't worry, we'll go through this. This is just in case you pick up these slides later and you want to understand what's going on. But actually, the typical, what we call a workflow with Git for an individual, and this is actually probably where most of you are. You're basically saying, why do I want to use Git? The idea is that you might have a repository here with some code and a branch called main, which is usually the default name, right? And all you're doing is you're just making small commits to it and pushing up to your own account on GitHub. And this is a way to basically back up your code, right? And I would encourage you highly to do this. And it might seem like there's an extra step in there because you're going to have to add and commit. But actually, if you use an IDE, this is pretty simple. And what is going to happen at some point is that you are inevitably going to break some part of your code and you can't control Z and undo things enough. Git allows you to go and make look for the differences between the things that were working and the things that are not. This will save your life at some point and will save you a hell of a lot of hassle. So I encourage you to do this. It might seem like it's too much of a step, but if you get used to it, it's pretty simple and it's good. Not to mention, if somebody needs to help you because you've broken something, if you've already using this, they will be able to help you much more efficiently. But actually the big strength of this, and I mean that, right, is actually for teams. So we'll just go through a quick example here just to show you where the strength of Git really lies. So this developer, Sarah, wants their codes on GitHub, and basically they decide that they want 2 new developers, Bob and James or whoever, to come in and make contributions, right? And normally you might invite them to this and get them to start committing to the main branch at the same time. Now this is possible, but it's going to lead to problems if people are modifying the same files together all the time. It's going to get conflicts, and if you've used Git and you've encountered conflicts in the past, it's a horrible message and it's a horrible feeling of, oh, this is broken and I don't know why. So this is the way that actually a professional team would normally use this stuff, right? So Bob would start by cloning the entire repository, right, to their local machine. And then they would create a branch off of main and start working on it. So that's the branch name in there called Bob working, or whatever, right? And they basically are committing new information to this branch. And it's basically parallel work. It's a different history. And when they push this stuff back to GitHub, it's actually just another branch on the GitHub account. And then James may do the same thing or something very similar. They clone the entire thing and then they branch off main as well to a different branch name. And I've deliberately used a very long name in there because actually naming your branches properly is a good idea. And you can name them anything. There's no limit to, I think there's no limit to character. Anyway. And both of these developers are working completely parallel. They started off from a similar point in time, and they're just working on 2 different things, 2 different features of this code, right? And then at some point, Bob is happy that they've finished what they want to do, and they want to make sure that their work actually is in the main branch, basically becomes part of the main part of the code, right? And so what they do is they go back to GitHub and create something, a pull request. And this is the bit that I mentioned earlier, right? Before all of their changes go into the main branch, which is the one that really anyone publicly should use, it really should be checked by someone. In this case, probably Sarah. So Sarah comes along, looks at the changes and goes, cool, I'm happy with this. Let's accept that request. And then all of that history, the main branch now contains all of the history of the other branch as well. Does that make sense? And Git is very good at making sure that all of this is going to work out nicely, right? That there are not going to be any conflict and stuff like that. In this particular case, everything worked out fine. And so this main here, if you notice, I apologize if you're colorblind, that's a slightly different color there from wherever it was before. And you can actually see that at this point in time, everyone else's main branch locally is a little bit old, right? But it makes sense, right? This does not happen automatically, and that's on purpose, because you want to make sure that you know when stuff is actually got updated. If it happens magically, at some point, stuff is going to break that you're not aware of. Right? And so at some point, James wants to do the exact same thing. Well, I finished my feature. I want that to go to main. But Git has automatically detected straight away that James has changed some stuff that conflicts with what Bob was doing, right? They might have changed the same file or changed a particular function in a particular file in a different way. And so at this point, Git actually goes, hang on, no, I'm not going to be able to do this. There are conflicts in here. And Git's quite good at merging things, but at some point he just goes, I don't know which of you is actually correct. And so the way that you would normally, or you can do it, right, is that actually James would get a notification saying, your pull request isn't going to get merged until you sort this out. And what they would do here is they would then pull main so that they have main completely up to date. Yeah. And they would go ahead and basically merge main into their own branch. Okay. And at this point, lots of tools can happen where they will show you where Git doesn't know what to do with the code. And given that James is the last one to do this, he's the one that actually should be deciding what things are, which is the correct way, right? And once that happens, then they push this up there. And at this point, there won't be any merge conflicts, and it can then be merged onto a last version of main. I'm sorry this takes a while, but it's just so that you can understand how this is all fitting into one place. And I'm happy to talk more about this. And just as a final point, you'll note that this is kind of like the final result. And at this particular point in time, Sarah and Bob have got the same version of main, but actually the one on GitHub is a little bit different because it contains everything from those two branches. And James also has a different one, which is why it's important to pull the changes before you start working on anything. But even if you don't, the moment you try to push them back, Git's going to go, hey man, there's stuff here that you don't have. Go and do that first, okay? Make sense? And cool. And one of the things I will mention is something called Git flow, which is actually becoming a very industry standard way of using branches. So if you imagine that you work in a company that actually distributes software and makes software available for people, let's say Netflix, right? This is basically, whether we like it or not, just a software company. That's all we do, right? They might have a main branch with the various versions of the major platform or some of their components, right? And then usually you have something called a develop branch. Now, this is the branch that the developers usually develop against. But actually, the developers never commit directly to develop. What they do is they create branches called feature branches, like what James's example was. They will make some changes and then create pull requests into develop. And several of these branches may be happening all at the same time. And I think the idea here is then the company at some point decides it's time for us to release a new version of our software. So basically, they branch away from developing to something called a release branch, which may just get tested. Somebody is going to bring it up, install it somewhere, run some tests, or more frequently, it's actually just automated testing. Right? Other computers will come in and click buttons and make sure that nothing breaks. And once the company is then happy that everything is working fine, then they will merge it into main and put a new version on it, right? In the meantime, all sorts of other work can continue to happen at the same time. So this doesn't stop anything, it's just stages of release and develop, right? Something just to be aware of if you ever go to an interview in a company, being aware of how things may work is a good idea. Anyway, you can have a conversation with somebody about this. And so just as a summary, Git is a version control system, and I think it's the version control system today. If you want to use it, I would highly recommend this because no one uses anything else anyway. And it's an industry standard, and it's for everyone. And I mean that it doesn't even have to be for code. As I mentioned, your thesis or your notes or something like that can be version controlled in this way. It's just text files, right? And it's easy to use once you get used to it. So I encourage you to get used to it. Before you finish any degree or any position here, if you are comfortable with this, this will do you good in the future. And integrates with all operating systems, pretty much every integrated development environment out there. And it basically works everywhere. This thing is designed to work everywhere. And I'll just make a final note in here, right? So the only caveat, and it's kind of a big one, is that it doesn't handle large files. And it's not very good for binary files. You can put binary files in there, but the difference is every time that there's any change whatsoever, it's storing another version of the binary file because it's not text, it's just binaries, right? So do not commit large files to your Git repository because it is incredibly difficult to then get rid of them. Even if you delete them, the history of you putting them there stays with the repository pretty much forever unless you go through a lot of effort. So try to avoid doing that. It's a pain. But if you do actually need to have large binary files versioned in some way, there's something called data version control. And there's a couple of other alternatives as well, which is this really is being used for things like machine learning models, which can be like, as you can see, like 500 megabytes. They can be quite large files. And the idea is that this allows you to have all of your code committed. And if the code then either requires or generates data in some way that's very large, you can have that data hosted in something like cloud storage and be able to just use and bring all of those things back as if you were using Git. Just something because sometimes it's useful. For example, if you're doing simulations in astronomy, your code generates a large simulation file, and you run your code 100 times probably at some point with different parameters, and you want to keep all of those 100 things. This is what you might want to use for that. Does that make sense? Cool. So let's move on. And again, if you have any questions about this, happy to talk. If you're having issues with Git at any point, come and talk to me, and we'll go through it. So, and the other thing I want to do now is talk about best coding practices. Now, I'm going to try and be generic about this, but I'm also aware of the fact that probably most of you use Python in some ways. So some of these examples will be kind of like Python here. And this is very brief. It's just mostly from my experience of looking at other people's code and going, what should be better in some way, right? So the first thing is indentation. Now, this is a no-brainer with Python because you can't have it without indentation. It just doesn't work. But if you're using anything else, right, this is not pretty. And it's very difficult to understand where the structure is, right? You turn it into something like this, it actually becomes more obvious what's a class and what's a function and what other variables in there. So actually, most integrated development environments just do this for you anyway, but it's just something to be aware of, right? Indentation makes the code more readable. But I will also say this, right? Don't go mental with it, because this is actual real code that actually works, and nobody likes this stuff, right? The moment you start having like more than 4 layers, you probably want to take that into another function somewhere, right? Don't go crazy with it, right? The other thing, and I think actually this is the most important one that I see all the time, meaningful naming of variables, modules, classes, and stuff like that will make your code way more readable by even yourselves in 6 months, right? Your variable is named A, the hell's that, right? Name it something useful, because what I find a lot is that people then go, they've named their variable A, and then they put a comment on what it's meant to be. Name it properly, okay? This means you need almost no comments. If your code is well written, and the days on when programming languages have limits on the number of characters is gone, right? So just you can name it something massive and it's fine, okay? This is the thing that if you're sharing this code with someone else, they're going to go and go, what is this, right?
This lifetime is 4 times.
Yeah, exactly. Yeah, in Fortran times when he was like, "Oh, you can't go any bigger than stuff." We don't need that anymore. It's good, right? And so, yeah, as you can see, like that code had lots of comments to explain what's doing, and this one has one comment in there. It's just go, let's do some multiplication, right? Because everything else is pretty obvious what it does from the naming of the variables, right? And then the other thing as well, and I actually get that question quite a lot, right? A Git repository is actually just a folder, and the Git is able to track anything inside of that folder and any subfolder in there, right? Having Git repositories with Git repositories inside is typically not a great idea, mostly because integrated development environments will get confused pretty quickly. So I would say, at some point today, if you haven't done this properly, if you've never had a thought about how to structure your code, think about that, right? Because if it's all lots of Jupyter notebooks inside of one massive folder with the data and everything inside of it all, it's kind of a mess because there's multiple projects in there. Try to segregate. Each individual project should be a different Git repository. And if they use common data, that's fine. Put that data somewhere else that they can refer to. To try and organize this will make your job much easier. We sometimes take breaks of 6 months from something and come back to it later, and then it's just a mess, like spits files everywhere and stuff. So think about how this actually should be structured. And you will find that if you go on GitHub and look for repositories, they will be structured something like this, where you might actually have only the source code in a source folder, and then you might have tests and stuff like that, and integration, and something else that allows you to deploy and put the code somewhere. Or you might have license files and requirements files and things like that that are not code, but they are associated with that thing. So organizing things correctly is a good idea. Maybe put your data files and your outputs in a different folder so that it's not in the middle of all of the stuff. Just a thought, yeah? And then the other thing as well, and this is with every programming languages, there are coding conventions, international conventions, that if you follow, it'll make it easier for other programmers that are comfortable with that language to understand what your code is doing. And Python is no different. There's something called PEP8. Go and have a look at that, right? And in fact, you can have tools on your IDEs that you can install, and they will force you to follow these kind of conventions, right? And these are things like, you use 4 spaces instead of tabs, and things like you should have lines of, no more than 80 characters, which you absolutely can in Python. The code works fine, but it's actually, this means that most developers use like computer monitors like this. And if you have more than 80 characters, it just goes off the screen. So it's nice to have longer code and stuff like that. Just little, like the community gets together and decides on these things. If your code complies with it, it's a little bit easier to understand. And the other thing as well is don't copy and paste your code, right? The moment it appears twice, it should be a function that you call twice, or it should be a class that gets used twice, right? It should be a module, right? Because at some point you want to change the logic of that, and then you have to change it in 26 different places, right? Really rubbish. Don't do that. And if you find yourself doing that today, it is okay to go and spend the afternoon undoing that, right? Refactoring your code often is a great idea, because every time you look at stuff you've done a year ago, you just go, oh, I was a much worse programmer. Let's do it again. Refactoring code is very important. Also, scripts and modules can have inputs, right, as well. So as you run your code, you don't have to be changing variables inside of the code. You can parse variables. The code could be the same, and you just have different configuration files or parameter files or things like that. Think about the idea of executing your code with different inputs all the time, okay? That's really the best way to do it. And the logic of how the code works should just be in one place. And so things like, core functions is a submodule, right? And the other thing I was going to say, and I mentioned that when I was talking about good naming, is that a lot of people tell you that good code needs to have lots of comments. This is controversial. I don't think so. I think if you name your stuff correctly, your code doesn't need any comment. Think about that idea, right? What are you actually commenting? Does it really need it? I would say, I encourage you to try and write code that you can understand without comments, because that's, I think, better code. And I was very shocked to find out about this when I moved from academia into industry. I started writing lots of code with lots of comments. And during the pull request, they were like, what is this for, right? Just write better code. Don't do that. You don't need comments. Comments are just lines that don't do anything. And I would encourage you to look into classes. It's something that actually people who do Python tend to ignore a little bit, because it's not obvious what it's for. And I'm here for the next month. If this is something that you're really interested in, come and talk to me. I'm happy to do a session on why this is a good idea, generally. It's particularly problematic for Python programmers because almost all languages force you to, the hello world is already a class in some situations, right? But in Python, you can kind of get going and spend years without even looking at this. But it's just something that's there, might be worth looking into. Yeah, and so which time have we got? 10 minutes, good. On the topics of code organization and things like that, let me just say a few words on Jupyter Notebooks for those of you who do Python stuff. These things are amazing, but they're often overused, I think, right? So let's talk a little bit about why they're good and what they're for, and just give you a little bit of a warning as to when it's time to stop, I think. So they're actually very intuitive to start out, and you have almost no requirements. This thing kind of just works out of the box. It's usually very nice. You install it, and then in your browser, there's a nice Python terminal-like thing where you can put lots of stuff, and it looks great. And it's great for playing with code and doing visualizations, right? Because you can have all of the plots in there and all the code executed. It's very nice to tell a story. I've used it extensively as a teaching tool. It's amazing, right? You bring it up and you can play, and you can interactively do things and see what the result is, right? And actually, I would say, I'll talk a little bit about our integrated development environments in a second. And there's plenty of advantages to using them instead of a browser. So if you haven't done so yet, think about actually starting using Jupyter notebooks inside your, something like Visual Studio Code or PyCharm or something. They work pretty well normally, natively, and you get all of the other advantages of IDEs in the process, right? But the warning here is that this is usually, if you're doing this stuff for your own research, it's for prototyping. And I mean that, right? It's kind of like, oh, I wonder if it's a good idea to start adding these spectra together or something like that, right? The moment you convince yourself that it's a good idea, that's when you stop. Put that code somewhere, which is a nice module, typically version controlled in its own thing as a proper Python or whatever. Because the moment you start doing anything more complex, you have caveats, right? So the first one is, and this is the big one, cell management is a nightmare waiting to happen, right? The idea of Python Jupyter notebooks is that you can execute the cells in different orders, and the whole thing is kind of like whatever it is at the stage you've done it, right? The number of times I've encountered somebody who's come and talked to me, and I'm going like, okay, just run your code. Then the person goes, right, okay, so it's cell 1, and then I have to do cell 4 and 5 and 6, and then 2, and then 5 again, because it's changed. Please, no, okay? But also, actually, code efficiency is pretty bad, right? This is not, in terms of like computer resources, this is about as inefficient as it gets, right? But also, version control becomes messy. So Jupyter notebooks are actually text files in themselves, but every time you actually execute code, even if you don't change anything, that technically is a different version of it. So when you start version controlling Jupyter notebooks, you're actually not version controlling your code. You're version controlling a thing that has your code, and that can get messy sometimes, right? And it's not production ready, it's not modular, so companies will never, under any circumstances, use Jupyter notebooks for production code or anything that's going to be used by anyone. And it doesn't actually encourage you to have good coding practices either, because it's supposed to be a quick and dirty thing, right? So just bear that in mind, right? It's nice if you want to, usually the best way to do it is you have your core functionality code in a module, and then you just import that at the top of your Jupyter notebook, and then maybe do some plotting, right? Visualization is great. Maybe play around with some of the variables and see where it goes. But really the core functionality, if you start finding yourself having lots of functions in a Jupyter notebook, maybe it's time to put them in somewhere else. All right, and I'm kind of running out of time, so I'll go through some of these things as well. So integrated development environments. In the past, a lot of people used to use Vim and Emacs. I'm a huge fan, but I think we've moved on a little bit from that point of view. Integrated development environments, things like Visual Studio Code and PyCharm and Eclipse are incredibly powerful tools, right? Because they integrate with all sorts of things and allow you to have a nice graphical way of doing code, right? And as you can see, most of them, this happens to be PyCharm, I think, but it doesn't matter, right? I actually say if you've never used one, without even knowing anything about how you run code or do anything, I think my suggestion actually would be Visual Studio Code these days. It's the one that is more kind of generic and it works with all languages. It has plugins, so go and find the plugins that apply to you and just start using it, right? But basically allows you to kind of like have a nice structure of your codes, syntax highlighting, the code looks nice. It detects, most of them automatically detect what language it's in and highlight things properly. You can execute the code directly in there without needing to have terminals open. It's a nice integrated environment. The other things that it gives you is stuff like code completion. So you start basically typing something and it gives you that, right? If you install things like the Copilot or kind of the ChatGPT ones, this is the same thing, but on steroids. It starts writing the code for you. It's nice. And so the other things it does is that actually for Python and for a few other languages, the moment you start putting a dot, it starts giving you documentation on how to use a particular function. Maybe a module you from someone else might have nice documentation associated with it, right? It also gives you things like code linting. Now, if you've never heard this word, the idea of linting is a check on whether or not it complies with those coding standards that I mentioned earlier. So you can install some modules and it starts like, the code will still work. It's not going to break your code. It starts underlying things and it's going to go, hey, your variable shouldn't be called B. Let's think about something else for it, right? It can get annoying a little bit, but it's like if your desire is to become a little bit better, this is a good way to do it. But probably this is the most important and powerful one, right? It does debugging for you, right? Really out of the box. You put a little dot before it and you can run it in debug mode and it will execute the code up to that point, stop. So you can go and investigate what's going on. It'll give you all of the variables you've defined with all the values up there. Now, you can do this on a Python terminal. Actually, if you use C or Fortran, you can actually still do this on these kinds of things. Just start using it. Your code's broken, you don't know why. You have some idea of where it broke. Execute it up to that point, and then you can visualize what's going on. You can stop and you can go line by line, slowly watching how things appear. You even have things like variable explorers, or even a little Python terminal where you can go and type the names of the variables and do certain Python commands at that point. Okay, this is super powerful for understanding what's broken with code. More often than not, you just go, oh, that variable is not meant to be that value at this point in the code. You just understand why straight away. And the other thing is, and this is actually probably more relevant if you end up working in industry, unit testing and integration testing is a critical part of making sure that software is good. And in fact, I would say that software that can be tested and is tested is a good step towards writing good code. These integrated development environments can even detect what parts of the software are actual tests, and you can run individual tests as well, like that. It's kind of a nice feature, but it's just something to be aware of. And usually code that's modular, in the sense that it's made out of little functions and stuff like that, is easier to test. Yeah. There we go. And in the last 2 minutes, I'll just mention one of the things that I said I would talk about. I'm going to do it very briefly, because this is the way that the industry is moving towards. If you've never heard of the word DevOps, and you are thinking about potentially leaving academia at some point, but actually, even if you are staying in academia, this is kind of useful to know, right? Most of the time that we write code in academia, the part that we care about is this bit. Okay, it's the bit that says code. And you may use some version control like Git, and you have your source code somewhere, and you typically run it in your own computer, and that's all very nice. Software engineering in industry has a lot more steps involved, okay? This is actually a philosophy for releasing code that is becoming a standard, and DevOps is actually quite a kind of a sexy word in the industry, in the sense like if you understand and you are familiar with these concepts, it's going to be quite good. So if you're thinking about leaving this and going to industry at some point, particularly if you want to be a data scientist or a computer programmer or anything that involves software, where the company will care about the software working well, there's a good chance they will use some variation of what's going on in here. Because code needs to then be built, needs to be tested, needs to be released, needs to be deployed, it needs to be in operation, right? And it needs to be monitored to make sure that it's working fine, and any problems get back through a planning stage onto the code itself. And this is kind of the infinity symbol relates to this. And what I'll mention as well is that along with all of these steps, there's a huge number of tools that allow you to do quite good things. So today we've spoken about Gits and things like GitLab where you host the code, but as you can see, there's actually quite a lot more going on, right? You may want to package your code into containers and you use Docker to run them in, but actually if you want to put them in production in such a way that people can use them properly, you may want to host it in something like a Kubernetes cluster. I'm sure that at some point some of you will have heard some of these names come up in videos or whatever, right? There's a whole host up there, and every single one of these has 20 different alternatives as well, right? But generally speaking, these kind of tooling is something that's quite useful to know. And if you are actually going to work in a company that does any kind of software in a serious manner, you'll also know that actually associated with each of these steps, there is often a team of people that only care about like that test bit or only care about that release part, right? So the kind of team names you might encounter might be things like release management or quality control or infrastructure, right? And so just because you think that actually the software development is what you're comfortable with, it doesn't mean that actually you can't fit in quite well into most of these other teams as well. And it's actually a good way to start into this kind of stuff to go into, say, the quality control part. Your job is to make sure that the code that somebody else ran is good, right? It's a great job, actually, because it involves a lot of critical thinking. You want to try and break it. What has the developer not thought about? If I click these 3 buttons in that order, is that going to break it? It's kind of fun, right? I did that for a bit. That's good. So just some final thoughts on this, if this works. So the more important thing today is if you're not using it, use it. And if you are using it, use it more. This is really important, right? And that good code is a journey. It's not an end goal. It's just a journey. It's always good to continue to think about what that is, right? And yeah, good practices are good to use, and there's nothing wrong with spending your time improving how your code is, even if you're not doing something more. Actually, making your code better will save you time in the future, right? And if you don't use an integrated development environment yet, I encourage you to choose one and get used to using it. It'll make it more efficient. It'll just generally be better experience, right? If you haven't heard of containers yet, kind of a nice thing to know about. It'll be good if you could talk about something like that in an interview at some point. And then, yeah, DevOps, or actually these days people are starting to call it DevSecOps for security, is like becoming a common methodology, something to be aware of, right? If you do nothing else other than spend 20 minutes just finding out what the hell that is, might be a good thing. And I'll mention also something like ChatGPT and other ones, right? This is changing the way we do code these days. It's just a tool, right? Potentially dangerous if you use it badly, but it is something that will make your experience better, right? So use it wisely, but use it. It's pointless not to do it. And I mean that at some point we're all going to be not actually typing code anymore. We're just going to be talking to a machine soon. And by soon, I mean it might be next year, right? You write your code by asking for stuff, and it'll just happen, right? Yeah, so I'll leave it there. Thank you.
Any questions?
So starting from your last point, I think we are not going to have code developers in the very near future.
Sure.
We are going to have askers.
Right.
People that ask the correct questions to develop code. What do you think on the evolution of that?
I think that's when ChatGPT first came out, whatever it was, not long ago, and this is, I mean that, right? Version 1 was out last year or something like that, right? I thought to myself, wow, in about 10 years' time, we'll all have a headset and we'll be talking to a machine, probably in something like Visual Studio Code. I think that's next year. I don't think it's 10 years, I think it's next year. And we're getting pretty close. But I think actually even the concept of a programming language, I think, is actually going to get it's going to disappear, because at some point it's just, this thing will just spit out binary stuff. And what you really need to know what it's doing, if you have enough trust that it's a common thing, that it's not weird. I actually think that's what's going to happen. Programmers are just going to become machine operators in some way, right? So yeah, maybe in 5 years' time, all of this is rubbish, right? It's all stupid. Well, why the hell would you do that? If you can just ask a computer to make a thing, right? The very concept of a computer program might actually start to blur out of other things, right? But I feel like we have to go through the journey. If you pick it up at the end, how do you know it's going to do the right thing? You have to understand that this isn't perfect by any means, right? It's getting scary good, but it's not perfect. Right?
Any questions? I have a question about a term used that I'm not familiar with. You talked something about when you have a function that is repeating too much within in a submodule, but I don't know what is a submodule.
So let me just go back a couple of slides if I can. Actually, no, I don't need to do that. So you can. So actually, this is quite. Are you a Python programmer generally? Okay, yeah. So you can structure your code to have something like a main.py script that then imports code that is inside of a subfolder, right? And if you put that __init__.py file, Python considers that to be its own module. And you can have things in submodules. You can structure and make hierarchies of other files that contain functions in a particular arrangement. What I mean by that is like things like you can have a large script in Python, a very long file that has lots of functions, might even have a class in it, might even have a couple of things, right? It's usually a good idea for most of the time when you're actually interacting with the code. You don't care about these functions very much. You've written them once and they're called somewhere else, but you find yourself scrolling through the whole thing when you want to get to the bit you care about. actually quite a good idea to just pop them in a directory and import this at the top. It might be a module of, called tooling.py, which is have a bunch of functions that just do stuff, right? You might have another one which is called astronomy package or something like that for whatever it is that you're doing at any point. It's nice to be able to segregate these things into what I'm calling submodules, but really these are just folders, right? Which also means that later on, if you want to share, maybe you don't want to share the entire thing, you just want to share the little kind of tools, the core functions. You can package it all up and give it to someone if they're already segregated, right? Because otherwise it's like, okay, so here's my Python file, ignore the first 2,000 lines and just go down to the end. It's not a great experience for anyone else. Does that make sense?
Yeah, thank you very much.
Do you have any questions online?
I have a question related to what Rogério asked. So we have been quite a while with Python as the main language in astronomy. Do you think, how long do you think this is gonna last, or if it's gonna last at all, or what is the next programming language that?
It's a good question. I think it'll last a little bit. I think Python is quite good at the things that I think astronomers like. I think the main thing that I think it's good is that the learning curve is very shallow, so you can get going very quickly. It implements things very quickly. Most of the time, if you want to do something fancy, there's a good chance there's already a module there, and the module probably has the name you imagine, and you just go pip install and it's there. That's nice, right? Python is bad at 3 things. It can do them, but it's bad at efficiency. So if you want to run stuff computationally intensive, it's not good. You can make it better, but it's never going to be as good as other stuff. It's not that great for web pages. I mean, it's nice, but it's not that great. And what was the other thing I was thinking about? It's not great for security. So if you want a programming language that forces you to have secure code that is hard to hack, I'd say Python is probably the worst, actually, at this, because Python will do things for you. It won't complain very much. It'll just do stuff. Oh, you want that variable to change to a totally different type? Fine, cool, no worries. Most other languages don't do that, and there's a good reason why they don't do that. And so I would say that I think for astronomers rarely care about network security and it's like database security. That's not something that usually happens. So I'd say that it'll continue to be probably a premier tool. Now, others are appearing and disappearing. Python has just become a thing now that it's kind of difficult to get rid of, right? It's a bit like how C is really, if you want efficient code, that's what most people use these days, right? I'd say that there are 2 languages that I think are coming up now, but I don't think that they're replacements for Python really, which is one of them is Go, which is really nice for cloud infrastructure. And I think there's a movement for astronomers to start using the cloud more, this mysterious thing called the cloud, whatever it is. And Go is very nice for this, and interfaces really nicely with that. The other one is Rust, which is trying to be somewhat halfway between C and Python. Very nice for security. In fact, part of the Linux kernel is now written in Rust, and actually almost all of the Google homepage is now written in Rust, so they've moved to something else. Interesting one to look at, but it's a different way of programming, and it's not an easy language to learn, but it's worth looking into. But I don't think that's like for data science, this Python is really nice. It's just all the visualization and stuff. It's pretty good. I think maybe for the next 10 years it'll still be probably different, but it's inevitable. It'll something else will come along. It's better. Sure.
I think what made astronomers use Python is because we need to ident your code and then you can read it.
Yeah, it forces you to do that.
I think
Sure.
that is the main.
Yeah, it makes that easy, right? Yeah, I agree. But I program in lots of different things, and I'm working in a project that uses various different languages. It uses Python for some of the stuff, but we use other things because for other things there are other better languages than this, right?
And what about the infrastructure for GPU based? What do you use? What do you recommend?
For GPU based, I think it depends on how you've structured your cluster of GPUs. That's not. Yeah, I think there are, if people are doing the beginnings of machine learning, I still think Python is a nice entry to it. Things like the Keras framework, for example, is really nice. It's just kind of like 10 lines of code, does quite a lot. But I think that if you want to use it for long-lasting simulations or something like that, at some point you have to, particularly if you have threading that you have to care about, Python's not that great for that. Again, possible, but not that great. I would actually say that actually C++ probably is the nicer option. But a lot of people won't, like, it's getting going in C++ to start with is a learning curve, right? It was never designed to be easy to learn. It was just designed to be very good on your computer. Right?
More questions? I have a question. Do you recommend to create a repository on GitHub or locally to push?
Oh, as in to when you start, right?
Mhm.
Actually, it's a good question, right? So if you have code or you have some files that are not version controlled yet, if you can create something on GitHub as a repository to use as your remote repository, and then you can create one on your local computer and then link the two of them. Actually, that process can be a little bit fiddly, particularly because when you create it on GitHub, often it already has 1 or 2 commits in there, and then there's conflict straight away. So my suggestion would be create one on GitHub, clone it locally on your computer, and then all of that link is already done. And then just put the files that you want to version control in there and start from that moment. It's just a suggestion. You can start it the other way, but it's a good question actually, because it's might not be that intuitive, but I would say this is how I do things. I create the remote first, clone it with the correct name, and then just move stuff and start adding. Because that way there's a singular history and all of the linking between the two is already set up. Good point.
And how often do you commit push?
If I'm doing lots of codes, every 2 or 3 minutes. But this is also because there's a few concepts I didn't speak about here, right? A commit should be a small change in code, because if you want to undo it, right? Undoing several small things rather than a massive one and then redoing some of the stuff you actually want. You know, there's things called cherry picking, where you can bring some commits from one branch to another. Often these are very small changes that you want to do. So yeah, I know. And I know that a lot of people don't, like, this is a debatable thing, but yes, I do it every 2 or 3 minutes, right? Often my commits are only to a single file on the repository as well.
Where should one keep the files?
Sorry?
Where should one, related to Thais' questions, where should one keep the files if they're massive catalogs like nowadays? We're
Sure.
just having massive catalogs that crash our computers and stuff.
Right. So this is where it all comes down to. I think the answer is more complex than we should all be all here. It really depends on what you want. But actually, catalogs tend to be like if it's things like I think the answer is always going to be in the cloud. Now, I understand that the model for paying for cloud stuff is something that universities absolutely hate, because they go, well, how much are you going to spend? And you go, well, I don't know, I haven't used it yet, right? I am very fortunate to work in a project where our leader just went, here's a credit card, don't tell anyone. Because you can estimate how much you're going to spend, but it's not a number, right? You get to the end of the month and they go, can we have $500, please, right? So, and it always obviously depends on how much you use it and etc. But generally speaking, I would say cloud storage means that your code should only be talking to the cloud storage when it needs some part, rather than you having to have a massive hard drive. You may structure your code to call the cloud directly and only pick up the files you actually want, even though you might have 6 terabytes of stuff. Your own personal computer doesn't need to have all of it at any time, right? I would also say that if this fits files and binary stuff, there's something called cloud buckets, and they're like directories in the cloud that you can just talk to pretty easily. If it's structured data, just information, databases are the thing to use, right? And they can have various different types, SQL or non-relational databases. They're all amazing. And you can host them in the cloud as well. So it's a central location for everyone. Which means that if you take your code and somebody else is using your code, they can still access your data. Now you can put credentials against it. And if somebody else wants to do it, you can create a little account for them and get them over there. This is actually something that DevOps people do a lot, right? But it's if you're deploying the code somewhere else to run somewhere else, that needs to have access to everyone. So I would say that that's probably one of the major aspects, right? Astronomy data sets are often in some server somewhere, but you have to download the entire thing before anything gets going. And I would like to see that change so that it's all hosted somewhere.
I think this is going to change with LSS. There is no way of doing that in that sense.
And yes, and I mean the other example, and it's like I've spoken and had lots of meetings with the people behind SKA. I mean,
No way.
there's a whole new level for things that they will be doing with data that it's just the idea we have today of how I like my folder to have my say goodbye to that very quickly. It just doesn't work that way. And in fact, actually, I had a meeting with the SKA people, right? Just DevOps engineers. It's not people who write code. It's just DevOps engineers who care about how the data gets managed and how the software goes. Their team is 40 people who do not write code because they have 200 developers who are actually writing code. And all they do is worry about what this data is going to do. And it's a whole different aspect.
Most likely we are not going to run our reports locally anymore. We are going to run them plus
Somewhere else or something that's more central. Right? So our project uses cloud infrastructure a lot, right? Just because of that. Also because I don't like maintaining computers in a room. Right? I just don't want to spend my time with this. I just don't like it, right? Because that will be obsolete immediately. And then you're gonna I have to buy this again. Cloud infrastructure just goes, it's someone's computer. Okay.
Cyclones and
Right.
whatever.
But actually-
Electricity power outages and so on.
On a more kind of practical level, we had that issue early in our project, and we don't anymore. I don't like VPNs. If that doesn't work, I have no access to anything. I don't like it. We have several institutions. Everyone has to be on other people's No, I don't like that. In the cloud, right? Let someone else worry about security. You pay them for this, technically, but it's not that much. And now it's available to everyone. Every member of our team, which spans 4 different institutions, can access all of our code without having to install a VPN client that breaks constantly. So I just don't like it, right? Universities love them, but I don't. So when the opportunity came to get rid of it, we did. And it's a good experience. A good experience.
Maybe we can talk more drinking coffee.
Yeah, sure.
Okay.
And João will be here for the next month.
Yeah, so I'll be here for the next month.
We'll get you a visitor's office if you haven't done so already. We can send around in the email.
But yeah, my email address is at the top of this talk, and I'm sure we'll share it with you. Just send me emails, ask questions. I'm happy to talk about all of these things. Right? I'm an avid user of Docker and containers, and I think it's great.
E vocês podem fazer as perguntas em português, a gente esqueceu de falar.
Ah, sim, sim, eu falo uma versão estranha.
Pode responder em inglês.
Exato, que às vezes é mais fácil. Né?
Let's think again.
Tá todinho?